All right. And so now let's introduce some of our vocabulary a little bit more formally. So we're going to operate on interval, okay? And that is you want to think of it as your time interval. It doesn't have to be time, but it can help to organize in your mind what we're talking about here. We're going to have continuous functions on that interval, okay? I'm not going to be having any jumps or gaps here. We call this set of points, f of t, g of t, as t runs over our interval. We call that our parametric curve, okay? So like it's this curve that's drawn in a particular way, okay? A curve that's drawn in a particular way. T is called our parameter. It is often, but not always, you can think of it as time. We say that the curve is defined by the parametric equations. So x, like the x coordinate is a function of time. The y coordinate is a function of time, or t, I should be saying, our parameter. Okay, our parameter. But time kind of helps organize it, at least for me, and I hope it does for you. We call this, when you have x is equal to f of t, y of t, we call that our parameterization. Again, like I've got the word paramet like over and over and over again, at least the beginning here. But we want to kind of like organize what we're talking about. And when you have yourself a closed interval like this, we can talk actually about initial and terminal points, okay? Because this is a curve that is drawn in a particular way, we have a first point and we have a last point if we're operating over a closed interval, okay? An initial point and a terminal point. Initial is for our first, terminal is for our last. So let's start to get our feet wet a little bit more with these. We're asked what curve is represented by the following parametric equations. The curve is drawn for us. It is indeed a circle, but let's step through this a little bit more carefully in the context of our definitions above. So we have x is equal to cos of t, y is equal to sine of t, t is our parameter. Our interval, well, that is from 0 to 2 pi as a closed interval. We observe that x squared plus y squared, well, the parametric equation for x is cos of t all squared. The parametric equation for y is sine of t all squared. That's cos squared t plus sine squared t. Well, that is always 1. This is an identity. Okay, that tells us that x squared plus y squared equals 1 is a circle of radius 1. But it's not just, oh, come on. But it's not just a circle of radius 1. It's a circle of radius 1 that is traced in a particular way. It's drawn in a particular way. Okay? And so where are we starting? Well, our diagram here is leading the charge. When t is equal to 0, we start at this point, 1, 0. When t is equal to pi over 2, we find ourselves at the coordinate 0, 1. Okay, when t is equal to pi, we find ourselves at the coordinate negative 1, 0. Okay, so it is important to figure out what the direction of movement is here. Well, moving in a clockwise direction. Nope, counterclockwise. Around once, okay? When we end up here at t equals pi over 1, t equals pi, 2 times pi, excuse me, around once. Once around, sure, okay? That's indicating that, like everything we want to know about this. So let's move on and look at this second example. Again, we have a picture to kind of describe what's going on, what curve is represented by the following parametric equations. Well, it's a circle, okay? But let's be a little bit more careful, okay? We need to talk about the direction of movement. And like, yes, it's drawn here, okay? But maybe we not like maybe we need to like step through this a little bit more carefully, okay? And convince ourselves so that in the future, when the diagram is not given for us, we're going to be able to argue this for ourselves. So I am going to urge you to always kind of go back and organize yourself with a table like this, especially when you're faced with something that maybe isn't quite immediate like a circle is. So T, X, Y. Okay. I am going to start with 0, and I'm looking at sine of 0. Well, that is 0. Okay. Let's do pi over 4. Let's do pi over 2. Let's do pi, 3 pi over 2. We don't have to hit everything. We're trying to get an idea about what's happening here. So sine of 0 is 0. Sine of 2 times pi over 4 is sine of pi over 2. Okay, and so that is 1. Then we get sine of just pi, well, that is 0. Sine of 2 pi, that is 0. Sine of 3 pi, that is 0. Okay, so I'm like 3 pi multiplying by 2 each time because of this. Then I go through and I look at cos. You can do these, you can go flat across each row if you want. Personally, I find it a little easier to sketch out a few just looking at one function at a time. There's nothing stopping you from doing an individual point at a time. And so cos of 0, well, that is 1. Cos of 2 times pi over 4 is cos of pi over 2. That is 0. Cos of 2 times pi over 2 is cos of pi. That is negative 1. Cos of 2 times pi, that is 1. Cos of 3 pi, that is negative 1. Okay. And so I'm going to write my point here. So I have the point 0, 1. I'm going to start there. Okay, so this is 0, 1 at t equals 0. Here I have the point 1, 0. Okay, that is here. Okay, it's not, I'm tracing, I shouldn't be. I'm going to go back. Make my blue dot actually on the circle. I really should, okay? Then I hit the point 1, 0. At pi over 2, I'm at 0, negative 1. Okay, so here I am way down here. Okay, so this is 0, negative 1 at t is equal to pi over 4. And this is t is equal to pi, oh, this was pi over 2. Excuse me. Okay. I loop back around and I get the point 0, 1. That's on top of this one here. Okay, this is t equals pi. Okay, and then last but not least, I'm going to do 0, 0, negative 1. And that's on top of this point here. And I'm left with t is equal to 3 pi over 2. Okay, so we are back again at the start with this red point. Okay. Okay, and we're actually moving in the clockwise direction this time. And what is our movement? How do we describe our movement? Well, 2 revolutions in the clockwise direction. Okay, so we go around and then we go around again. All right. And you can fill in more points as you need to kind of convince yourself of how this stuff works. I'm going to pause and we'll start a fresh slide movie video.